This is a classic beautiful problem for question 12. It looks like an evaluation problem where students might panic because 10 degree is not a standard angle. But if you have trained your brain to spot patterns instead of just memorizing formulas, you will recognize a legendary trigonometric trap waiting right inside the numerator. Let's look past the non-standard angle and use a classic class 11 manipulation to collapse this entire expression in seconds.
Hey thinkers, welcome back to Think Sharp Alley, where every turn leads to a smart solution.
The first step with any odd trigonometric expression is to ground it back in sine and cosine. Cosec is 1 by sine and sec is 1 by cos. So we rewrite the expression using basic reciprocal identities. Then we take the common denominator. So once we take the common denominator, which is the product of sine and cos, the numerator becomes cos 10 degree minus root 3 sine 10 degree. And once we take a common denominator, the problem reveals its true form, a hidden linear combination in the numerator and a classic half angle form in the denominator. Look at the denominator first. We have sine 10 degree, cos 10 degree. So if we multiply the numerator and denominator by 2, we can use the sine double angle identity. And the numerator, whenever you see an expression like this, it should immediately trigger one idea in your mind. Make the coefficients, which is 1 in this case and minus root 3, make the coefficients look like standard trigonometric values. So if we keep a 2 outside and multiply a half inside, now this becomes interesting because half is sine 30 degree and root 3 by 2 is cos 30 degree. So for the denominator, we use this identity and the numerator we rewrite like this. Now the numerator perfectly fits the identity sine A minus B, which is sine A cos B minus cos A sine B. Here in place of A, I have 30 degree and B, I have 10 degree. So sine A minus B is sine 20 degree. Now if someone chose to substitute first half as cos 60 degree and root 3 by 2 as sine 60 degree, it would collapse into a cosine identity instead. But we need sine because in the denominator we have sine. So we wanted sine identity, and that is why I chose to write half as sine 30 degree and root 3 by 2 as cos 30 degree and not the other way around. So the numerator becomes 4 sine 20 degree and the denominator also becomes sine 20 degree. The sine 20 degree term cancel out beautifully, giving us only 4. So the correct choice for this question is option D, 4. So when non-standard angles show up, always look for identities that force them to compound and cancel. If you solved this without reaching for a calculator, drop a thunder in the comments, subscribe to Think Sharp Alley, and I'll see you in question 13.